Hello everyone, I'm Xiaogan. Now, we will start writing some APIs for our libwebp. And we are starting with the lowest level API of libwebp. The lowest level is this one. We will start writing from the bottom layer. Actually, for this step, you can put it into this. Actually, before officially entering this phase, you still need to go into the C++ project. That is, create a new C++ project to dab this libwebp API to see if it runs successfully in a pure C++ project. Only then will you move it here. Move it into UE. Since I have already confirmed that it runs successfully, I can move it in. So how do we do it? Actually, we do it like this. First, we declare a struct. Personally, I prefer using structs. Of course, it depends on each person's development habits. Some people might prefer using namespaces. That's also fine. I just like using structs a bit more. Okay, let's call this struct. Normally, we should write comments for this, but we won't write them here. Because this is based on a mature plugin, you can access the plugin source code. In the plugin source code, we have a bunch of comments written. This is the C++ API. Don't use it. If you want to use it, you should call our Unreal Engine C++ API. Those places should be where you are allowed to use it. We won't write comments here. And here, note that here, we check it. This place must be UTF-8, because if it's not UTF-8, if you have some string type stuff here, it might cause issues with Chinese characters. Just like when we typed just now, we couldn't see it in the editor, because we found that we cannot see it in the editor. Secondly, comments will be lost. Yes, comments are easily lost. Your comments often become garbled. Then after we have such a struct, let's do something mischievous, because we said we don't want you to use this thing, but we still want to use it ourselves. So we'll make it a friend. Currently, we don't have the struct yet. So let's also create a struct here while we're at it. Okay, good. Then here we'll name this struct this name. We'll place this struct here for now. We won't write anything yet. Mainly, we're doing this to conveniently make it a friend. That is to say, it can be allowed to access this protected method here, because this is equivalent to a protection we implemented ourselves in the plugin. We don't want the user to directly call this API, because during the process of calling it, they might not understand. That is, they don't understand the process from C++ to C++. They will just write code randomly. This will cause many problems. Then we write the first interface. We can explain the first interface. This is to generate a static images web. You only need to pass in an image. Then you specify the height and width of the image and the quality of the image. Then this will save the image to this local path. Yes, okay, so actually here we can return the binary data of this generated image instead of swimming int direct. But sometimes considering that, but why is it that here we provide a safe path instead of returning a piece of it? Is because if this thing is not written into UE5 plus C1 plus, we call this libweb with this underlying lab. Just bundle this file with these several files. If we package it into a DL, when we call it from other places, generating such an image path can sometimes be more convenient. Once everyone is familiar with it, you can change it like this. Let's type it out here. This kind of encapsulation can take various forms. It depends on your needs. Let's just give it a force for now. Okay, so this is our first API. So how should we write the first API? It's actually very simple. Let's include our header files. First, before we include the header files, we need to do this. Let's first define under Windows. We will only include these because they can only be used under Windows. Then let's do it as we write. There might be some warnings here. That is when we encounter warnings later. I'll tell you how to resolve them. So obviously here, we also need to make it under Windows. Only then will this code be executed. Okay, then we make a judgment on it here. Because this quality factor, we consider it to be between 0 and 100. If it is less than 0, we set it equal to 0. And if it is greater than 100, we set it equal to 100. Normally, 0 won't be passed in. Seeing 0 is still a bit strange. Then at this point, next, we declare a pointer of type unitate asterisk. We have to declare it this way, because in a similar position, it is this class in std. It is no longer unate. It is a type like unitate. It is actually a pointer. At this point, we directly call this API. Call this API. Okay, and here you might, these parameters here are the parameters we passed in. Right, you see, pay attention. Here, this is this one. This is the pixel data passed in. That is the actual RGB value. For example, if it is EK, it's a piece of data with a length of 1920 times 1084. Then it's the height and width. Then what does this mean? This is essentially, it means multiplied by 4. You see, this is the stride parameter. Yes, here, this y value needs to be multiplied by 4. It's equivalent to 4 ones. Remember, that's the idea. Then this is the quality. We set it to 100. Actually, regarding this quality, we should, this content, we should put it here. But we still used 120 on our end. Okay, so what does this output mean here? This output is actually the pointer it outputs. Let's connect this pointer. This is a one-stop shop call. Then the location ask. And then it returns this compressed data. If it's 0, it means a problem has occurred. And note, this data must be released using this method. And this quality is controlled by this thing from 0 to 100. And 100 hides the best quality. We use the best quality. So actually at this point, our image has already been generated. If the size here is equal to 0, it means we have a problem. We just directly return false. And then once we have this data, we can convert this data into a T array in the form of U of 5, etc. 8. We won't convert it here. Yes, everyone can improve it on their own. We'll use a native C++ approach to store it to this path. Okay, is this the blood flow for opening a file? Then save it in this WP format. And if it exists enough, take this data, the length of this data, right, and this data's, this is the position of this file. Input it. After inputting, we close this stream, and finally, we release this data. Then we succeed. Okay, actually, here we also need to check whether this path is valid. Is it valid? So we are judging this path externally. Therefore, we haven't implemented a processing method for this path here. Okay, actually, if this doesn't exist, it means there is a problem here. A problem, actually, we need to return false here as well. Yes, then we need to release it here as well. Yes, it needs to be released. Okay, so we've basically written this mechanism. We can try compiling it now. Hey, okay, let's take a look. You'll notice that the compilation actually failed. There is a warning here. The warning can be ignored. And this one has an unanswerable code. We probably don't need to worry about this unanswerable code, right? A bit strange, it says unanswerable. Let's take a look at how to fix this issue. Actually, this unanswerable issue is also easy to solve. Let's just write it like this. Let's use this condition. Let's write another underif here. Let's do it this way here. Okay, that should be fine. So this interface generates based on an RGB value. Actually, let's just finish it now. And then we expose it to this. Expose it to our call. Now let's write the call class. At the bottom level, we have written this class. We come here. As for this class, we actually need to add the export macro because we want you to use this class. So we add the export macro like this. As for this export macro, we actually use this module name. Change this module name. Remember to use all uppercase. Counter-shift plus U. We should be able to compile successfully now. Here I used class. it doesn't matter. Actually, here we are, just using it as a place to put classes, so you don't need to change everything. After using class, let's write our first API. For the first API, let's simply create a board. Generate a one-shot static web picture, and here it is passed down like this, because all of these are our U classes. Looks familiar, right? Like it, F class, T class, F class. Then let's create its implementation. I'll move this down here. Then let's write the code inside. First, we need to check if this path exists. If the path does not exist, I'll directly return false. So how do we write this method to check if the path exists? Here, we need to use some knowledge we learned earlier. Obviously, these are some common methods, right? Let's put it below. These are some static methods for internal use only. This is the path we pass in, right? Let's first write the methods inside. So first of all, we need to get the current, its extension. Let's check the suffix first. Then get its directory. This class, I don't think it's necessary to explain it to everyone, but it's very useful. It just makes the path. Get the clean file name, clean path. This gets the file extension. Right, that is, we have all the WebP file, and here we get the current directory. Then we check the current extension to see if it equals WebP, and at the same time, whether the path exists. Then we consider it passed. If it fails, we log it here. We consider it a failure. We really need to include a log here. We bring this log in, put it here. Then here we need to include the same file. We put it here. Okay, so then we make a judgment. Why didn't we log at this layer? Not at this layer. The reason for logging at this layer is because here we can only use native C++ stuff. Because during the architecture design, we explained it to you in the previous 2 episodes. Here we can only use C++ or C-like things. Okay, we used cPwn here. Later, we can see we also used C++. Then we made something like this here. And if the verification passes here, we will continue to proceed. Then we also need to check the color you passed in. You can see F color is actually a pixel. It is RGBA. Color is an RGBA. It is 4 bytes. That is the pixel data. We check if the pixel you passed out does not match the pixel width and height. Then the data you passed in is incorrect. It does not meet the requirements. Length and width like this. Set it up like this in the image. Then we consider your data to be incorrect. Then it's time for us to win. As for the earlier part, actually, we can write it like this. Let's write it this way. Because we explained earlier, you can use some methods provided by F to implement and display it in its execution code area to help you locate it. Okay, like this. Let's just paste the log here. Then this indicates it's wrong again. So we need to make a judgment. Some of our programmers are like this. You must have a relatively complete logical thinking. Otherwise, you really won't know what he will pass into you. Then here we can convert this path, this PTR path, into a pointer. You can convert it like this. Okay, this way we use the tchr2ac macro. So you cannot write Chinese in this image. And this macro is actually very dangerous. In one of our own strings, I have told everyone that this macro is very dangerous. We also say it like this. The writing here is quite dangerous. Let's review why it's dangerous. That is, the path cannot contain Chinese characters. Secondly, if the path is too long, it will be truncated. If the path is too long, it will be truncated. Then this T chart to S. This pointer will, this pointer, this string, this pointer will be recycled very soon. Yes, it will be recycled very soon. In the end, it's very dangerous. Then we continue writing below here. Then we go, you can see here, this layer mainly converts these Unreal Engine things. The first one is done. Now we convert the second one, which is this data. You see, the data is of this type. It is a pointer. On paper, it's written in C syntax. So here we make it an unsigned char pointer. You see an unsigned char pointer. Then we allocate a block of memory. This block is the total number of pixels multiplied by 4. We add another 0. After adding the 0, we clear this memory block. Clear it all to empty. After clearing, actually, we can use memory here. Using FemMorate is perfectly fine. Earlier, I demonstrated it in the speed section. We still write it this way here, because that's how it's written in my plugin. Then we start here. We create an INT here. Then we need to process it. This step is very critical. The reason for processing is that we need to invert the A channel here. The A channel needs to be inverted. Why do we need to invert it? Because if you don't invert it, this A channel actually behaves differently from the A channel in UE5. Sometimes it works opposite to what we think. If you don't invert this value, then the image you export might be completely black or completely white. At this point, you need to consider whether the RGB value you passed in is correct. Obviously, here we can use F color. F color directly gives us RGBA. Then invert the A channel. That's the operation. Okay, so what do we do next? Next, we control this, which is the incoming quality coefficient from 0 to 100, because I really don't know what data the user will upload. So we need to protect these as well. Then all this data is converted into the C language type. When it's in this style, we can directly call this API. You can see here, we directly call this API. Of course, at this point, this API, we need to change its name. That's no problem. We need to include the header file. This part is also fine. Then you'll notice that the header file here actually doesn't include any native C or C++ code. We include the arbitrary code like this. That way we can get the result back. But no matter how well we do, we need to take this pointer that we pulled out and recycle it. Then set the location this pointer points to as null. That is, the resources you applied for must be released. So we can just return this result. Actually, this interface should preferably be executed asynchronously. And this asynchronous part is external, called externally. Then you must use this interface asynchronously from the outside. No, the outside must use this interface on other threads. Otherwise, it will block the main thread. Okay. Someone will say, that is, why not allocate threads here to handle it? Okay, it's because we want to encapsulate this interface layer by layer in terms of granularity for everyone. Then we will later encapsulate threads within the subsystem to use this interface. That is actually our top level encapsulation. So because of this plugin, when I talk about the plugin, it's precisely because it goes layer by layer. I think when I first encapsulated it, I felt that encapsulating it in this way was... But actually, at this point, we have already completed this interface. Okay, now we still don't have a way to test it, because this thing of ours needs to be connected with the previous step. Right now, we've only done the latter part. We haven't connected it with the previous step yet. We'll show you in a moment how to connect it with the previous step. And that's all for today's lesson. Thank you, everyone.